Ok, buenos días. Pues bueno, vamos a empezar la presentación de uso y aplicaciones de madera para exteriores. Nada más antes de empezar, me gustaría darles una pequeña introducción sobre qué somos Softwood Export Council. Un segundo. Ok. Bueno, Softwood Export Council es una organización comercial que trabaja para promover el desarrollo estratégico del mercado de la exportación de los productos de maderas suaves fabricados en Estados Unidos. También, nuestra misión, con la ayuda del Servicio Agrícola Extranjero, podemos crear una presencia en el extranjero para la industria. Tenemos actualmente 4 oficinas, una aquí en México, otra en Inglaterra, otra en Japón, otra en China y la central que es en Estados Unidos, en Portland. Entonces, con todas estas oficinas podemos actualizar a nuestros miembros sobre las políticas económicas en constante cambio en todo el mundo y también podemos darle las herramientas educativas a los compradores potenciales y crear demanda en nuevos mercados. Las actividades que nosotros realizamos siempre son con un plan estratégico y objetivos de producción medibles. Se crea y desarrolla actividades de promoción en mercados internacionales para la industria de la madera y también mantiene relaciones con representantes de la industria extranjera, como por ejemplo nuestra relación que ahorita tenemos con Comaco, para que podamos llegar a más personas. Y también se llevan a cabo investigaciones sobre mercados emergentes. Algunas de las actividades que nosotros desarrollamos durante el año, por ejemplo, el año pasado fue atípico, pero hemos estado en diferentes expos como Expo SIAC, Expo Ferretera, Expo Tecnomueble, y por ejemplo este año pues depende cómo se vaya desarrollando, esperamos estar en Expo Ferretera en Guadalajara. También hacemos seminarios y en estos momentos webinars para poder seguir dando educación de la parte de la industria maderera. También hacemos misiones comerciales a Estados Unidos donde invitamos a importadores y clientes potenciales que importen madera de Estados Unidos para que conozcan los aserraderos y a las empresas en Estados Unidos. Y al mismo tiempo también hacemos misiones comerciales a diferentes países en donde, por ejemplo, vienen las personas de Estados Unidos a México a conocer a los importadores y a los clientes potenciales para que puedan tener un vínculo más cercano y se conozcan. ¿Dónde nos pueden encontrar? Nos pueden encontrar en nuestra página de internet que es www.seclatam.org, también a mi correo electrónico que es tania@softwood.org y a nuestras redes sociales que es Facebook, Instagram, Twitter y YouTube, en donde van a poder encontrar diferentes materiales educativos. Y pues I would like to introduce you Butch Bernhardt. Butch is from Western Wood Preservers Institute and will present usos y aplicaciones de madera para exterior. Thank you, Butch.
Thank you. And let me, oops, hit the right buttons. There we go. Buenos dias, and thank you for joining us today. As Tanya mentioned, my name is Butch Bernhardt. I am the Senior Program Manager for Western Wood Preservers Institute, and we're located in Vancouver, Washington, which is just across the river from Portland, Oregon. And we represent the wood treating industry in the West, the 17 Western states and 2 Canadian provinces. Today, I'd like to take some time to talk to you about preserved wood products and hopefully give you an idea of how those products are made and how they're used in outdoor exposures where there's a threat of deterioration with the wood. Here's just a quick overview of what we'll be talking about today, and hopefully at the end of this you will have a better idea of how preservative treated wood is made, specified, and used in construction today, and I hope that the information you get today will help you to understand how you might use it in some of your projects in Mexico. Here's just a quick look at what I'll be discussing today. We'll start looking at the history of preservative treated wood and how we make it today, and why you need to protect wood from deterioration, the standards that guide both the manufacturing and the use of the products, and then we'll explore how and why we use preserved wood in construction today. So let me start with just kind of a basic introduction about what is preserved wood. Now, preserved wood and treated wood, it's been known as treated wood. We prefer the word preserved in discussing these products, because that is essentially what we're doing. We're preserving these products to make them last longer than what would be possible when you use them in exposures where it's exposed to the elements and to insects and other things that can deteriorate the wood. Now, as you know, wood is unmatched as a building material. You know, it's strong and it's light, but you can work it with very basic tools. It's readily available. It's environmentally friendly, and most importantly of all, it's sustainable. We have a resource that's just that's renewable, and we've over the past century, we've in the United States, we've made a lot of gains in being able to have a forest resource now to provide products and for the future. And when you think about it, you know, wood is really the culmination of just a few real basic inputs. You take soil and water and seeds, and then over time, these trees capture carbon and grow to a size that they can be converted into products for building materials. Now, it takes typically about 30 to 80 years for these trees to grow large enough to become where they're able to be converted into products. And one of the things that we do with preservative treating is that we can extend wood's natural life from just a few years to many decades when used in place. And so that means that when we come to the end of that service life for that product, a new tree can be grown to a size large enough to be converted into a replacement product. So that's you know, that sustainability is a key element on why preserving wood and extending its life is so important. Now, you know, wood is really made to grow and die and then break down into organic material to start this cycle all over again. You know, and that's great when you're in the forest, but it's a little bit different when you have converted that wood into a building material. You don't want that material to break down too quickly, and that's been an issue from the beginning as we started using wood. And over the centuries, we in civilization have figured out how to slow that deterioration. This photo here is of a staved church that's in Scandinavia. This building is over 800 years old. Now, this building was not made out of preservative treated wood because 800 years ago there was no such thing as that. However, through design, they figured out ways to enhance that. Well, wood is used in a lot of different areas throughout the world, different climate conditions, and so what the practices they use in Scandinavia are far different than what you would see in Mexico or in the United States, for that matter, and where you have many more opportunities and risk for the wood to deteriorate. And so when you want to protect that wood, you need to protect it from basically two types of organisms that seek to break down wood. The first is decay fungi or rot, which seeks to break down the wood fiber and return it to an organic material. The second is wood destroying insects who use wood for homes and also eat it and break it down. And these range from termites to borers and in marine conditions, worms that dig into the wood. Now there are approximately 100,000 species of fungi in the world. It's actually one of the largest organisms by number in the world, and they are really ever present in our environment. We're probably breathing some small microscopic mold spores, fungi spores, as we speak. And when it comes to wood, decay fungi needs four basic things to break down the wood. It needs suitable temperature, needs moisture, it needs oxygen, and it needs a food. Now, in this case, the food is the wood. And so when we're using wood outdoors, it's really impossible to control the temperature or control the moisture and the presence of oxygen. So that leaves us with one thing that we have an opportunity to change, and that's the food, the wood, to keep these organisms from breaking it down. Now, the danger that's posed by decay is that it may be difficult to see. Now, you see in this photo, this is an underside of an outdoor deck that has been painted. Now, when you look at that photo, all that wood looks pretty good. However, an infrared scan that's shown below shows that parts of that wood underneath have decayed, and it's likely that decay began when the paint was applied. And depending on the moisture conditions, that decay will continue to expand within the wood and break it down, and it could significantly impact the load carrying capabilities of this wood. Now, insects are another risk that to wood, and insects do serve an important purpose in breaking down the wood from dead and dying trees, and they'll actively search for dead wood. Doesn't matter if it's in a building or in a forest. They are pretty much guided to do that. And so if the conditions are right and they get access to that wood, they can cause significant damage. Each year, wood destroying insects cause $5 billion US in damage to wood products in the US, particularly in the hot, humid climates that you find in the Gulf Coast and other parts of the country. So how do we protect the wood? Well, the best way is we use preservatives to change the wood so that it becomes less desirable for fungi and insects. And we use wood's unique characteristics to create a protective shell around the wood. And this protection is not just on the surface of the wood, it goes deep into the fiber so that it does not come out and provides a lasting, durable protection. So let's talk about how we create this protective envelope and how we use preservatives to do that. Efforts to protect wood are as old as civilization. Ancient records dating back to Greece and Egypt talk about preserving wood, and oftentimes they preserve the wood for protect structures for wartime and other things. The first commercial pressure treating really began in the mid 1800s, and it was developed as a way to protect ship timbers from deteriorating in sailing ships. Soon it was discovered that you could use it for other infrastructure uses. And so when we first began treating wood, it was for things like railroad ties, utility poles, pilings for docks and marine facilities. The first standards for treating wood were published in 1904. And throughout this past century, the process of pressure treating, along with the development of a variety of different preservatives available, resulted in billions of board feet of wood pressure treated and used throughout the US. And these products range from sawn lumber and plywood to large pieces of wood like utility poles and marine pilings. Treating is really a straightforward process, and really hasn't changed from a process from when it was first began. We've used technology to do it much more precisely. Now, in the US, there are basically 3 species that are pressure treated and available in the market today. In the West, we treat Douglas fir and hem fir. And in the South, the product that's treated most often is southern yellow pine. And in terms of volume, there is much more southern yellow pine available that's treated. And part of that is because southern pine treats very well. Douglas fir and hem fir, you can pressure treat them, but they're a little bit more difficult because of the fiber structure that's in the wood. Now, the start of the treating process, treaters buy lumber and timbers and plywood from sawmills. They actually are buying the same product that would be available for used in the untreated form for construction lumber and the like. And so these treaters buy these products and bring them into their operations. From there, they'll sort them and may trim them depending on the product. And then in the US, particularly here in the West, we may stain that wood to create consistent color prior to the treating process. Another thing that we do for products that are going to be used in a ground contact use, where they touch the ground, where there's a higher risk, we do incising, which is cutting slits into the wood to allow a path for the preservative to get deep enough to provide the necessary protection. I'll talk more about that here in a bit in our presentation. The wood is then prepared and moved into a pressure cylinder, which we call a retort. And it's basically put on carts, and these retorts can be up to 43 meters in length. Then once the wood is inside, a vacuum is applied, pulling the air out, and then preservatives are pumped into the cylinder. And then over time, pressure is applied that moves the preservatives into the fiber of the wood. And this is done increasingly with new technology, where we can control exactly the conditions within the cylinder to produce the product. And the time it takes to do this treating depends on the size of the product, the species, the final end use and of the product, and what you're treating to in terms of protection. At the end of the treating cycle, the wood, the preservative is pumped out of the cylinder and moved to storage tanks to be reused. It is wheeled out into a sealed drip pad where any excess preservative can drip off of the wood. Representative core samples are then taken to assure that the proper level of treating and the proper amount of preservative is in the wood and that is deep enough to provide the necessary inspection. We do have third-party inspection companies that come in and take samples as well to confirm the plant's quality control is accurate and that the products will do what they are intended to do for that specific level of protection. The finished products are then moved into a storage area. Well, they'll be maybe covered with a lumber wrap to protect against any surface moisture on the way to the job site, and then they are ready for use in whatever application, whatever job site. So again, this process really is pretty straightforward and hasn't changed much. But we have learned a lot over the years on how to do this, and the plants that do this today are very, very good at doing it and making consistent product that can withstand the risks that are out there for deterioration. So, how do we use preserved lumber today, and what do we use it for? Well, there are a variety of preservatives that are available today to protect the wood, and these preservatives are indeed chemicals, because we are trying to keep insects and fungi from deteriorating. So it does need to be robust enough to provide that protection for the long term. Now, all the preservatives that are used in the U.S. undergo a rigorous review by the U.S. Environmental Protection Agency, or EPA, and they must approve and they register these preservatives, and then regularly review how these preservatives are used and any potential health effects that may come from that. And as a result, we have a pretty extensive record of performance, and there are national consensus standards that guide the use of these preservatives on how much we use for the necessary level of protection. So, when you think about preservatives, they are one of the misconceptions of these are really strong chemicals. But in reality, the active ingredients to today's preservatives are also found in many other products that are used in everyday life. The preservatives used for the residential products that you'll find, things like decking and treated wood for structures, is typically a copper-based preservative, and soluble copper is the main ingredient in waterborne preservatives, which I'll talk about in just a moment. Copper is mixed with other fungicides and biocides to provide that protection. And copper is a very effective deterrent against termites and fungi. The other ingredients, the biocides and fungicides that are mixed with it, are the same chemicals that are found in many consumer products. These include azoles, which is a biocide used in protecting food, flowers, and agricultural products. Quaternaries is another biocide that's used that is also found in disinfectants and household cleaning products. Borates is another one that you can find in eye drops. It's a natural mineral. And so one of the key things to understand about this is we've got these preservatives in the wood, how much is in there? I mean, and it's really important to keep a perspective on that, to understand that. And the amount of preservative is guided by the national standards. But just to give you an idea, if you take a 2x6, which would be a piece of lumber such as this, 12 feet in length, that if it is treated for an above ground application where it's not touching the ground but still exposed to the elements, the amount of active preservative in that piece would represent this much. Now that same piece treated to a ground contact level where the risk is much higher, you would have 2.5 times this active ingredient within the full length of this 12-foot piece. So it's a relatively small amount compared to the size of the piece, but this amount is effective enough to make that wood last in place for decades. Now, the treating standards and the use of preservatives and the amount of preservatives that we use are defined in national standards that have been developed by the American Wood Protection Association, or AWPA. And the AWPA Book of Standards establishes the retentions, the amount of preservative in that piece, as well as the depth, the penetration of that preservative that's necessary to provide that protection. And those standards have been set based on extensive research of the preservatives, where they've been put in place at various sites to check, in some cases 20, 30, 40 years, to ensure that they are providing that necessary long-lasting protection. American building codes reference AWPA standards when, in terms of guiding the use of these products, and defining the conditions on where these products can be used. Now, there are two basic types of preservatives based on what is used to carry the preservative into the wood. Now, waterborne preservatives are mixed with water to carry them into the wood. And these are found in products that are used in residential and commercial construction that are exposed to the weather. Now, here are the main waterborne preservatives used today. And they're mainly known by their acronyms, although they're often sold under their brand names. There's the most popular preservatives that are used in residential and commercial projects today are the copper azole, or CAC for Western products, and then MCA, or micronized copper azole, for Southern pine. The only difference between these two is that in the micronized copper azole, the copper molecule is much smaller. It's ground much finer than for the copper azole, and it works very well for Southern pine. You don't find any MCA used in Western species. They use the CAC copper azole C formulation is the one used mostly, but they still provide the same protection. Others are ACQ, ACZA, which contain copper. CCA was for many decades the main waterborne preservative. Today it's not available for residential use. In 2004, the industry responded to concerns because the CCA is chromated copper arsenate, and arsenate is a form of arsenic, and there was concerns about the arsenate, even though there's been no scientific evidence that shows that has caused any health problems. But out of an abundance of concern, the industry decided to withdraw that from residential use, but we still use CCA today in agriculture for posts, agriculture post, and it's used quite a bit in utility poles, Southern Pine utility poles. Other preservatives include, oh, sorry, let me go back. Include borates, SBX-DOT. Borate is a mineral. It's a water-soluble mineral, so it's often used in to provide protection from insects where it's protected against liquid water, because the exposure to water may wash some of that protection away. And then the newest preservatives that are available out there are carbon-based preservatives. These are sold under the brand names of PTI and EL2. These don't have copper in them. They're predominantly the biocides and fungicides that I spoke about earlier. These products, for the most part, can only be used in above ground applications. They are not approved for use in ground contact. The probably we'd call these infrastructure preservatives are the oil type preservatives, and these preservatives are carried into the wood with an oil based liquid, diesel, mineral spirits, biodiesel has been increasingly used, and these are used. These preservatives are used in really demanding conditions, things like utility poles or marine pilings and the like. And there are a number of these that are available today. Copper naphthenate is an oil-borne preservative. It's also used in field treating, which we'll talk about in a moment. It's a non-restricted use pesticide registered with the EPA, according to the EPA, so it can be available as a consumer product. Creosote was the original preservative that was used for wood. It's used predominantly for rail ties today, but for many decades it was the chief preservative used in the U.S. Pentachlorophenol is used extensively for utility poles and cross arms here in the country, in both the U.S. and in Canada. The newest is DCOI, and DCOI has been around for about 20 years, but received approval a couple of years ago, and is used in utility poles, bridges, and the like. And then IPBC is another one that has use in things like timbers and bridge parts that are available. Okay, all of these preservatives, their use is guided by the standards, and the standards set up what's called the use category system. And this was developed by AWPA, and they're really based on the risk of deterioration in the intended use. So the use categories are a numbered category, and the higher the number, the higher the level of risk. And so all wood uses can really be placed in one of the 5 use categories that are described within the standards. And within each use category, there are subcategories for varying levels of protection. So, simplicity is really one of the keys to the use category system. And so when you're talking about a use category 1 and 2, that's your lowest level of risk, maybe for insects. So it's going to be for your least demanding conditions in interiors where the wood may be protected from exposure, but there still may be some risk. UC 1 and 2, for example, are used in Hawaii. Hawaii requires all framing lumber to be pressure treated, and typically these products are treated with borates to UC 1 and 2 because the framing lumber is going to be protected against moisture. The UC5 is your most demanding conditions. This is going to be for marine applications where it's going to be submerged, immersed in water, or face regular wetting where your threats are from not only decay but from marine borers. So again, just walking through very quickly, UC1 is an interior application, and really UC1 and UC2 are really only separated by the potential of moisture. UC2 is for those applications where there may be occasional dampness. One of these applications in the US would be the sill plates, the first board that goes down in a house that's placed on concrete footings where you may have some moisture coming from the concrete as it dries. And again, this UC2 is also what you see in warm, humid locations where or termite-prone areas. As a way to protect that wood that may already be sheltered through the design from exposure to moisture. UC3 is your above ground category. UC3A is for wood that's typically used outdoors and exposed to the weather, but protected in a way that allows that water that may be on the product to quickly dissipate and evaporate. Things such as vertical walls. UC3B is what you'll find mostly in the market for an above ground treated product. UC3B is for wood, is really designed for wood to take on all exposures, regular wetting from things like rain or snow. But it's also not in contact with the ground, so there are opportunities for that moisture to dry as the weather conditions change. You see UC3B products used for decks and deck joists and beams and things like fence pickets, where they're still exposed regularly to moisture, but have the opportunity for that moisture to evaporate. UC4A is your ground contact, and it's traditionally been used for ground contact applications, but a few years ago the standards were changed to recognizing that there are some uses where the product may actually be above ground, but may face very similar risks to ground contact in terms of organic material on it, constant wetting of the product. And so there are some above ground uses where you would use a UC4A ground contact level of protection. The standards have language for products that are considered difficult to repair or replace, or applications where wood is exposed to water both naturally or artificially. UC4A treated wood is commonly used for deck framing, for posts, for timbers and other structural products where you need that protection. When you put it in the ground, you've got constant moisture and potential exposure to insects, and so you need a higher level of protection. UC4B is for really heavy duty ground contact applications. And this ranges from posts for buildings and agriculture to utility poles and piers that are just above water line and may only have exposure from splash and the like. And finally, UC 5A is for things like marine pilings. There are 3 subcategories, A, B, and C. And these are the A, B, and C are determined by where that product's going to be used. 5A is for areas above San Francisco, north of San Francisco. 5B is for below. Basically, where you've got colder water, you have a different types of marine borers. And when you get into warmer waters, such as the Gulf Coast or below San Francisco or below New York in the east, a different type of borer. And so there are different types of protection that would be available for that. For typical residential construction, we do have an infographic that is available that shows the potential use categories for that application. That's available on our website. We have a Spanish language version of this available on the website and at preservedwood.org, and I encourage you to check that out. We have some other information on the use categories that are available in Spanish language as well. Okay, let's now talk about some important information when you are going to be using preserved wood. All preserved wood products that are used and sold in retail locations will have an end tag, and that end tag will provide the important information about that product. It'll have the use category for it, the condition, in this case above ground. It'll have the name of the preservative that is used. It'll have the retention or the amount of preservative in there, which is measured by pounds per cubic foot. It'll identify the company and the plant where the product was treated, and it'll also have a registered trademark of the third-party inspection that ensures that this product will meet the specified use category regulations for that. These end tags will look different. Here is an end tag, and they'll be different depending on the preservative. However, all of the elements that are shown in this will be reflected in that end tag. And so through that end tag, you know what type of product you have and what level of protection it has been treated for. I mentioned a little bit earlier about Western products, Douglas fir and Hem-fir, and the incising. Incising is basically sent through a machine where small incisions are made into the wood, and this provides a path to get the preservative deep enough to provide the necessary protection. And above ground products for Douglas fir and Hem-fir typically don't need to be incised. You can get it deep enough to meet those requirements. But for ground contact, where you have much higher risk, that incising is needed. These are only for Western products, Douglas fir and Hem-fir. Southern pine readily accepts preservative, and it does go deep within the wood. So you won't find Southern pine being incised. And so if you see incisions, you'll know that it's likely a Western product, a Douglas fir or Hem-fir species. As we talked about the preservatives, I noted that one of the main ingredients in the preservatives are copper, and so when you're talking about fasteners using with preserved wood, the fact that you have copper and then you have the steel within a fastener These are two different atomic weight elements, and as such, there's this condition called galvanic corrosion, where the copper in the preservative can begin to corrode the fastener over time. And so fasteners such as nails and screws need to be protected against that through galvanizing. And so building codes require that any fasteners used with preservative treated wood be high quality, hot dip galvanized or stainless steel. With galvanizing, you're creating basically a layer of zinc that provides protects that steel from it. And so all preservatives, copper-based preservatives, have recommendations to use this. The AWPA standards and building codes require the use of high quality galvanized fasteners or stainless steel. Silicon, bronze, and copper fasteners can also be used, but those are usually for just specialty type of things. Stainless steel, and you'll see stainless steel a lot in marine applications where you've got exposure to heavy duty exposure and exposure to seawater. Field treating is another requirement. Again, when we talk about protection, we're talking about a shell protection. It doesn't go all the way through the wood. And so as you see with a piece like this, your protection is here, but this middle area has not received any preservative and then is subject to deterioration from fungi or from insects. So when you are cutting or drilling holes into preserved wood, you can open up a pathway for these deterioration agents to move into the wood. And so by field treating these, by using a solution containing copper naphthenate or oxine copper, you can maintain that protective envelope with those cuts. And we've done over the decades, we've done a lot of testing on field treating, and it is a very effective way of keeping that protection and extending the life of that, and not allowing a path for decay or for insects to impact the wood. Treated wood could really be handled the same way as untreated products. We encourage you to use some common sense precautions. We recommend you wear gloves and long sleeves to avoid slivers, and make sure you wash your hands after handling, and particularly before you're eating or drinking or smoking. Wear a dust mask when you're sawing to protect against inhalation of wood dust, and wear goggles to protect your eyes. It is important to properly dispose of any scraps or any used preservative treated wood in a project. And in all states but California, treated wood can be disposed in regular landfills, the same as untreated wood. And if you can, we encourage you to recycle. In a lot of cases, that wood still has a usable service life and perhaps a different application. In California is currently has restrictions on disposing of treated wood. There have been some changes recently, but they are moving towards. For the last almost 20 years, you've been able to dispose of treated wood in composite line landfills. The legislation for that expired. There's been some political things surrounding that, but the state has started issuing variances that allow people to continue to dispose of it in composite line landfills, and we're hopeful that new legislation will be adopted this year that puts that back into place. And we definitely encourage you not to burn treated wood because of the chemicals that are in it, and those go into the smoke. And so we certainly discourage its use in burning or in fireplaces. All right, I'd like to talk now real quick about best management practices for using preserved wood in aquatic or sensitive environments. You know, when you're using preserved wood near water and near sensitive environments, there are, you know, we recognize there's a need for balancing the protection of the wood with the potential impacts of the preservative in the wood to the environment and any of the wildlife behind this. And so we as an industry have developed best management practices, or BMPs, that were intended to guide the industry and guide users in maintaining this balance and minimizing the amount of preservative that may be available in the product to move into the environment. And so our specifiers guide offers recommendations on how to safely produce, install, and then even remove existing preservative treated wood products in these type of areas. And these are really all based on the core philosophy of using the right amount of preservative to protect the wood against the conditions where it's used in, but minimizing how much of that could move into the environment and could have an impact on the environment. You know, the BMPs require using preservatives that have been approved by the respective agencies in either the US or Canada, and they must be used under consensus treating standards maintained by each industry in the respective countries. To help specifiers, we've developed a computer model that really allows you to predict the potential environmental impact when you use it in water and in sensitive areas. In these models, you can actually define the conditions on where it's going to be used, things like the water flow and you can see the potential impact for 11 of the most commonly used preservatives. And these models have been accepted by both state and federal agencies in assessing the potential impacts from using preserved wood in these applications. Excuse me. Because BMPs are really above and beyond the typical treating practices, it does typically take a bit longer to produce that. And so we encourage any user that wants to purchase lumber that's been produced under BMPs to get in contact with the supplier and work directly with the supplier so you can properly plan to have that product available when you need it. You know, treating practices that are used to treat wood under the BMP requirements have been thoroughly tested by research done by Oregon State University and other universities. And they offer flexibility for the producer to treat and meet the BMPs. There are also requirements that are defined within the BMPs for third-party inspection so that independent eyes can come in and make sure that these products have been produced to the specified standards. one of the really important things to note is that the BMPs are really a shared responsibility. They are not only the producer has a set of responsibilities, but the user, those people that will be installing the products. There are certain requirements to make sure that that you don't expose the environment unnecessarily to the preservatives. So things like field treating them, making whatever cuts and holes in it prior to treating, creating sawing stations where you collect the sawdust to make sure it doesn't get washed into the environment. Those are all things that in the specifiers guide are laid out for users to ensure that they are compliant. Products that have been produced to BMP standards can be marked with this logo. It can also be displayed on any of the documentation for the wood from the producer. And again, it's really critical for users who want to use wood that's under the BMPs to from the outset work with the producers and find and talk with them and use their expertise. And then once that wood arrives on the job site for users, it's important to inspect it, and if there are any issues with the wood, to immediately contact the supplier and get those resolved right away. And as I mentioned, cuts and holes should be field treated, and you need to make sure that you do these away from the water, that you're not hanging over the water and brushing on field treatment because it could fall into the water. Also, the demolition of the existing structure. In a lot of cases, where you're replacing things like a bridge or a dock and removing the wood. So you want to make sure that all of that is removed properly and handled properly. Okay, we're near the close of my presentation today, and in closing, let me talk a bit about the environmental benefits of preserved wood. And as I led off today in talking about this, what we're doing is taking a really remarkable product and extending its life, which in itself has some very valuable sustainability aspects to it. It as a renewable product, we do have the ability to extend its life so that another tree can be grown and be of a size that it can create the replacement product, and we can do this far into the future. But we also understand that some of these environmental benefits really need to be assessed on a more objective and science-based approach. So what we've done as an industry is we've prepared a number of internationally recognized life cycle assessments, or LCAs, that allow you to compare the full environmental impacts of preservative treated wood versus the alternative materials. And over the past decade, we've commissioned a series of these LCAs comparing preserved wood to the alternatives. And these studies really provide a cradle to grave perspective on products, and they're conducted under the ISO 14044 standards that are internationally recognized for life cycle assessment. I'm sorry. And the results have been confirmed through peer review as these LCAs have been published in a variety of environmental journals. And as you can see, if you by looking at this graph of 7 key environmental indicators, wood has a significantly lower impact on the environment. And these indicators include things like emissions of greenhouse gases, fossil fuel use, water use, and ecological impact, and things like acid rain and smog. If you see the green bars, and these are normalized values, but the green bars are wood, and as you can see, much lower impact on the environment compared to steel, such as steel framing, concrete, composite plastics that are available out there. And we're certainly not. There are appropriate uses for these alternative materials, but if you really want to look at the environmental impacts, using an objective process such as LCAs really does underscore the environmental value of using wood. So with that, I appreciate your time today. We're going to have some time for questions, but I hope you've learned some new things about preserved wood that perhaps you didn't know, and it will help you in deciding whether to use this product in the future. We know there's a fair amount of preserved wood used in Mexico today. We believe Mexico has a unique environment. And in some areas, preserved wood would last for decades in place because the risk levels, given the climate there. Coastal areas, there may be more of a risk, but the preserved wood can provide that necessary protection. And we're confident that they can perform well for the applications that you have. As I mentioned, we have a variety of materials available online to help you further understand that. We have a full technical library available on our website at preservedwood.org, and encourage you to review that. We have a couple publications that are available in Spanish language for you to review. And there are also a number of other associations that we work with that can provide additional information should you need it, and I encourage you to check those out. And so with that, I'd be happy to answer some questions. I see there are some questions there, and I'll go ahead and leave this slide up. And Tanya, I'd be happy to answer some questions.
Okay, we have two questions. The first one is, before preserved the lumber, it should be kiln drying or air dry, or both?
Both. In southern pine and hem-fir are predominantly treated for a dry basis. Douglas fir is often treated when it's green. Part of that reason is because a lot of Douglas fir produced in the West is produced as green. Douglas fir is a very stable species. It dries well in place, and so with the treating, in some cases you're withdrawing the natural water in there, is replacing it with the mixture of water and preservatives, and so. So yeah, but the other species are dry, and by the time it completes the treating process and goes to the job site, the products are relatively stable, and all wood continues to dry to its surrounding environment, and so you see that with treated wood as well as untreated. Other questions?
Yes. The second question is, the reclaimed wood, it's on fashion for floors and wood furniture and decoration. It's possible if the reclaimed wood is already preserved again for the new usage?
So wood used for furniture. Yeah, it can be used if, for outdoor furniture. You know what? It is safe if you're going to be using it in that type of application. One of the things that to keep in mind, though, again, is that if you're constructing something out of pressure treated wood, and then making furniture out of it, there are opportunities where you may open up areas of that wood that have not received treatment, and may be subject to deterioration. So those are one things to keep in mind. It is difficult to pressure treat it after it's been assembled, but you can certainly it's certainly possible to do that. There may be other ways to protect that wood. You know, the thing with furniture, as opposed to, let's say, a deck or maybe infrastructure like you know, a retaining wall or utility pole. You know, with those applications, you're intending that to last for more than a few years. Furniture tends to be, you know, you're going to use it for you know, maybe 8 to 10 years, but then styles change and all that. So you know, there may be other ways to protect that wood that are for that application that may not require pressure treating. Okay.
Okay, other question is, does pressure treatments allow the solution goes into the hardwood and sapwood in the same way, or depend of the
Yeah, that's a great question. Basically, with wood treating, we're only treating the sapwood. The sapwood is of species is more readily accepts treatment. Heartwoods, the wood changes a bit because the tannins in the wood, and heartwood offers some level of protection as well, and as well as the, you know, when you look at wood, it's really under a microscope, it's really a series of straws, and there's openings at the end, there's openings throughout it, and those openings tend to close in heartwood as it goes, is surrounded by sapwood. Species like southern yellow pine is what's considered a thick sapwood species. So there's much more sapwood in southern pine, which means that which is why it accepts treating very readily. Douglas fir and hemper are considered thin sapwood species. So there's much more heartwood within those two species. And so as a result, when we're treating Douglas fir and hemper, we're only treating the sapwood of it, and the heartwood it's difficult to get preservatives to penetrate the heartwood. And so you are talking in treating, you're talking about the sapwood. That's what we're treating.
Ok, otra pregunta es, ¿el impregnante DCOI cómo se aplica en la madera?
Yeah, sure. DCOI is again the newest preservative. It is an oil-based preservative, so it is carried into the wood. Can be mixed with a diesel or other petroleum type product to be carried into the wood. Again, DCOI is really one of the newest preservatives that are available out there. It received approval for use in utility poles in 2017 through AWPA, and we're seeing it become established in the market, and And again, mostly we're seeing it in utility poles. And so that's where it's been targeted by its manufacturer. It's being promoted as an alternative to pentachlorophenol, which may be in the future not used because the single manufacturer of it is discontinuing that preservative. So yeah, we will see it for that infrastructure type uses. It's unlikely you will see it for residential products. You may see it for things like bridge timbers, but it's mostly going to be for utility poles.
Perfect. And the last question is, ¿qué vida útil puede tener una estructura de pino a la intemperie tratada con CCA y con bajo mantenimiento?
Well, again, it really depends on your location and the environmental conditions where you're at. But we've seen CCA has always been an extremely durable preservative, and it's worked very well. It's not uncommon to see CCA, things like CCA decks and structures last 30, 40, 50 years in place. Now, you do maintenance, there's kind of this fallacy that there are materials out there that require no maintenance at all. And the reality is some maintenance is required. And you can enhance the durability of a treated product with, every few years cleaning it, maybe using something like a clear water repellent over it to enhance that durability. Monitoring that structure that every few years to ensure, again, part of when you're talking about decay, it can start in places that you may not be able to see, and so you want to be able to check through that. But yeah, and then today's manufacturers offer a limited lifetime warranty on the treated wood products that they're selling, and the intention is that these will be used for 20, 30, 40, 50 years in some conditions, with ensuring that they are properly installed, that use the proper fasteners, that use field treating, and those sorts of things. So yeah, it is possible for a very long life.
Okay, another question is, ¿qué vida útil puede tener una estructura de pino a la intemperie tratada con CCA y con bajo mantenimiento?
Yeah, I think that's what I just answered.
Yes, sorry, sir. Okay, wait a second. Ok, una vez instalada la madera, por ejemplo, en un piso de alberca o al exterior, ¿cuál es la diferencia? ¿Cuál es la diferencia entre CCA y pentaclorofenol?
Oh, well, CCA is again, CCA for one is a waterborne treatment, and so we do see there is much more use of CCA in Mexico. We see CCA for things like decks around the swimming pool. You don't find much in the way of pentachlorophenol. Pentachlorophenol is really an industrial preservative, and it's really intended for infrastructure type applications. So I think CCA for use in a deck structure around a pool. The fact that it's near a pool, it's going to be regularly exposed to moisture, you might be considered a ground contact type of risk, and you might want to make sure that that wood is treated to a ground contact level of protection to get the best protection and best potential performance for that. But yeah, it's not unusual to see decks like that last for 20, 30, 40 years.
Okay, and the last question is, una vez instalada la madera, por ejemplo, en un piso de alberca o al exterior, ¿qué precauciones tomar o qué riesgos puede tener la madera Yellow Pine MCA?
No? Yeah. Okay. Well, for a precaution for it, again, I don't think there are, in terms of maintenance, it's just, you know, I regularly clean it over a few years, make sure to you know, check it out to make sure that you don't have any decay starting. It's, you know, and again, with Southern Pine, you know, Southern Pine is pretty durable, and treated with CCA, you can get a good long life on it. But remember, it is wood, and wood, it's going to do the same things when it comes to, you know, if it's exposed to a lot of sun and dries, you know, you could have some dimensional stability issues depending on the conditions there, and that's one thing to keep in mind. How you install it, you know, the bark side down, where your growth rings are pointed down, because wood, you know, all wood changes like that. You're taking something that's round, you're creating square and rectangular pieces out of it, and sometimes those may dry unevenly, and you need to account for that. And you do that with proper installation, making sure it's near its moisture content at the time you put it in, things like that.
Okay, we have two more questions. What is a mill standard treatment for a pallet's wood? If possible, can you talk a little bit about the wood market?
Okay. Well, let me answer the pallet question. Most pallets are not pressure treated. Most pallets are going to be, you know, they're really intended for short-term use, and so pallets are under regulations. They are heat treated to protect against any insects that may be in the wood that would move to another country and could create some issues. And so pallet stock in the US must be heat treated, and it brings it up to a heat high enough to kill any insects that may be in the wood. Pallets are usually made from lower grade wood products, and which may be, you know, from the outside of the tree, where you may have the potential of having insects in there. So we don't know of any pallets they're using treated wood. There may be some out there, but for the most part, it's not known. As far as the lumber market, this is, you know, the past year has been a unique year, has been unexpected in terms of economic activity. You know, as the pandemic started this spring, we had a number of, you know, stay-at-home orders. Businesses were were asked to close down to protect employees. And we saw, in April, a big plunge in economic activity, and many sawmills and treating plants closed down. And then suddenly it roared back. People were staying at home, and instead of traveling, they decided that it'd be a good time to build a deck or build something outdoors. Home building returned and was very strong. And as a result, mills and treating plants could not make enough wood to meet that demand. And by September, prices for both untreated and treated wood reached record levels, almost triple of what it was in the spring. We've continued to see those high prices through this year. Housing has remained very strong. Repair remodeling has remained very strong, and that's a big market for treated wood. People have been working from home, and as they work from home, they look around their house and have spent a lot of time there, and they've identified areas where they want to make improvements, and creating outdoor spaces is one of those improvements that they've taken. And so there's been really strong demand. And, our outlook is that these strong markets are going to continue. There's a lot of indicators that show that housing is going to continue to remain very strong. And there'll be a lot more, the home construction activity is going to continue. And we are anticipating that demand for both treated and untreated products is going to remain strong. The sawmill industry is working to fulfill that demand, but there are other factors that come into play, and they're not as readily available to really crank up production to meet that. So I think the prices, lumber prices reflect the supply and demand conditions in the marketplace, and at this time there's much more demand than there is supply.
Okay, other question is, ¿qué tan flamables son los preservantes para la madera?
No, they're for the oil-borne preservatives, creosote, they are carried by a petroleum product, and so there is some potential there. The waterborne preservatives, no, they are no more flammable than untreated wood. Again, your ingredients in waterborne preservatives are copper and biocides and fungicides, and so that doesn't affect the flammability at all.
Okay, another question is, ¿es mejor estufar la madera primero y luego tratarla con CCA?
Yeah, I mean, I think that is a typical practice of drying it and then treating with CCA. Again, you're going to be, you dry it, and then when you put it into the cylinder, you're flooding that cylinder with essentially water with preservatives mixed in it, and then moving it through pressure into the wood cells. It's certainly not going to be as wet as it is naturally, because you've removed moisture already, and then over time that's going to dry, and it's going to dry immediately after it comes out of the retort. But it's certainly not to the same level as it was in nature, where you've got a moisture content of 30, 40, 50%. Even with the treating, again, you're not treating the whole piece. You're creating barrier around it, and so it's far different, and so it will be a stable product.
Okay, and the last question is, do you think it's convenient to use wood as a structure for some buildings in Mexico?
Absolutely, absolutely. I believe that wood structures, and there are both. You can use treated or untreated. Again, with untreated wood, through design, you can create conditions where you can protect that wood from deterioration. It's just in those applications where it's more difficult to protect the wood against exposure because you're using it outdoors. A treated wood product would be more appropriate for that. And so, yeah, I think you know, wood is a remarkable material, and I think in Mexico, particularly given you know, the earthquake potential for earthquake within the country, wood structures do very well under earthquake conditions, and wood framing designs can withstand those type of events much more readily than concrete or masonry and the like. So yeah, I think there are very many opportunities for wood structures within Mexico.
Okay, perfect. Thank you very much. And I think someone raised the hand. No. Okay, thank you very much, Butch, for the presentation. It was great. And before we end this presentation, I want to introduce you Manuel Elorza for Comaco. Manuel. And also I want to introduce Rose Braden. Rose Braden is the president of SEC. Manuel, no sé si te quiera. Ahí está.
Ahí está. Ok, ya. Soy Manuel Elorza, represento al Consejo Nacional de la Madera de la Construcción. Muy buenas tardes, Bosch. Muy buenas tardes a todos. Antes de que termine la sesión, quiero expresar mi agradecimiento a la licenciada Tania Basavilbaso, también a Software Export Council por el apoyo otorgado, y sobre todo mis felicitaciones a Bosch Bernhard por su brillante presentación. Felicidades, Bosch. Muchas gracias. Adelante.
Ok, pues muchísimas gracias a todos por haber asistido a este webinar. Thank you very much, Butch, again for your webinar. It was great. Y bueno, cualquier duda que tengan, por favor, háganosla saber. Nos pueden mandar un correo o ya, bueno, ya tienen nuestra página de internet o las redes sociales también estamos ahí para cualquier duda o aclaración que tengan. Muchas gracias a todos. Thank you very much, Rose, Butch, Manuel. Muchas gracias.
Muchas gracias a ti, Tania. Solo un aviso para los del curso. Ahorita cerramos la sesión y nos metemos al ID, a la link de Comaco para continuar con el curso.
Thank you. Bye-bye.
Right. Thank you.
Está hablando y tenía apagado el...